One type of non-Euclidean geometry is elliptic geometry or spherical geometry. This app right here actually represents spherical geometry. This is a sphere. You'll be able to see it a little bit more as we play with it and get some objects drawn on there. But it is a sphere that you can rotate. In elliptic geometry, the surface is a sphere, but lines are called great circles, which are the circle that goes around the widest part of the sphere. I think it's kind of useful to think about the globe as our surface, and then the equator would be a great circle, and so would all of the lines of longitude, and those would be the ones that go from North Pole to South Pole. So the controversial part about geometry is Euclid's fifth postulate, the parallel postulate, which states if you are given a line, here's a line, a great circle on our sphere, and a point that's not on that line, Euclid's fifth postulate, which was accepted for about 2,000 years as being true, said that there's exactly one line that's parallel to our given line that goes through that point. In spherical geometry, there's actually no lines that are parallel. There's no such thing as parallel lines on a sphere. They all intersect. No matter where I try to put this, it's going to intersect the given line that we have. You can recreate this yourself using this spherical easel app. You can move these points around and try to figure this out and play with it and make sure that you see that there are no such things as parallel lines. They all intersect at basically at the poles. And you can rotate so you can see the point of intersection a little bit better. Some other topics about elliptic geometry that are pretty interesting. We already said there's no such thing as parallel lines. Also, if you draw a triangle, so let's get a third line on here. You can even do a segment, it doesn't really matter. And you look at that triangle, if we look at the angle measures, I think because I use that segment it won't show me the angle measures, but if you look, that looks like that's 90 degrees, maybe a little bit more. Same thing here, and obviously this angle is not 0, so the sum of the measures of the angles is more than 180. In fact, if you were to use two perpendicular lines and the equator, if you think about the globe, it would actually be possible to make a triangle with all three right angles. So the angles could be 270. But any triangle in elliptic geometry, the angles are more than 180 degrees. Another thing we can talk about, let's draw another line and a perpendicular line. And let's do another perpendicular line through this point. Here's another example of a triangle that has more than 180 degrees, because those were both 90 degrees. We made them be perpendicular. And these appear to be nearly perpendicular, at least. Maybe they are. If we add a point onto this line, and let's make another perpendicular line through that point, what I was trying to get here is 4 right angles. We have a right angle here and here, and these 2 angles were also perpendicular, and these 2 lines were perpendicular, so that's a right angle. But really what I'm showing is that it's impossible to make a rectangle. We have 3 right angles, but when you do that, the 4th angle will not be a right angle. So there's no such thing as rectangles. Another pretty simple thing we can look at is if you have 2 lines, no matter how you draw them, in Euclidean geometry, lines can only intersect once, but in spherical geometry or elliptic geometry, they intersect twice, basically at both poles. And the last property of elliptic geometry I want to talk about is with triangles again. There's basically just no such thing as similar triangles. If 2 triangles are similar, then they are congruent. If the angles are going to be the same, then they have to be the exact same distance apart. You can't keep that length without changing the angle. Or you can't keep the angle without changing the length. It's kind of hard to demonstrate, but if you perhaps play around with spherical geometry on your own, you can start to see that a little bit.